So far, we've looked at some fundamental programming and processing. We've looked at creating shapes and writing functions, using for loops for repetition, and most recently, investigated how we can write code to make decisions in our programs based on the value of variables. In this video, you'll see how you can apply your knowledge to a practical data science problem. This will involve a number of steps that will be useful for solving any problem with programming, analysing the question, breaking the question down into components, and then writing the code for each of these components. Presenting data is very important to helping people to decide which course of action to take. Graphs in particular are a very common way of presenting data. So the problem we're going to look at in this video is how we could present some data by using a bar graph. The data we want to display is the whole numbers from 0 to 9. Then, depending on some characteristics of the viewer, we want to modify how we present the content, with viewers who identify themselves as being red-green colourblind receiving more text and different colours. Colourblindness, where people perceive colours differently because of their eye structure, occurs quite a lot, and having alternative presentation schemes that work for all users is a very common way to address this important accessibility issue. Using what we know so far, how would we design this program? To start, we want to divide the program into its individual parts, or to use a term that we use a lot in programming, we want to decompose it to simpler, smaller parts. This will make the task easier to understand and more manageable. One part of the problem is creating the data we want to display, another is displaying the data as a bar graph, and another is changing how we display our data based on the viewer's request. Let's start with creating some data. Seeing as the data is a simple sequence of numbers from 0 to 9, we can use a for loop here. And here's the code we can use to do this. Our loop variable I starts at 0, as this is the first data value. We want the values to go from 0, our first, to 9, which is going to be 10 numbers in total. The condition of our for loop will be while I is less than 10, which will stop after we've used I equals 9. We increment I by 1 each loop to get the numbers 0 to 9. Using this loop, we now have the data values we want. We can access these from within the for loop using the variable I. Once we have our data, the next step is to create a simple display. We set the size of our canvas to 400 by 400 to give us enough space to draw the graph. Because we're drawing a graph, we want to display the axes for our bar graph. As the axes won't change, we want to do this outside of the loop to minimize needlessly repeated code. To display things evenly, we can divide our canvas into a 12 by 12 grid, storing the size of each grid square as a variable. Then, using the grid scale, we can draw our axes like this. This will draw the vertical bar offset from the left edge of the canvas by the value of scale, and the horizontal axis offset from the bottom of the canvas by the value of scale again. Now we have our axes, we have a nice place to display our data. And we can do this by using rectangles where the height indicates the relative value of the data. The scale variable is going to be useful here as well. We can use this to ensure that our data will be nicely aligned on the same grid that our axes are based on. The code for adding our bars looks like this. We want to draw each value in the next grid location, and this is why we use scale times I plus 1. Notice the negative value we give as the height. In processing, the y coordinate increases down the canvas. So to draw our squares from the bottom corner upwards, this must be negative. We've chosen a black background to make things really stand out, and because we want to really see the differences, we've used a bold red-green colour palette. But as we noted, not everyone sees colour the same way. So we've now created and displayed our data on a nice grid. What else do we need to do? Well, we also need to change how we display the data if the viewer wants to avoid red-green colour combinations. The code for changing, depending on the viewer, looks like this. The variable RG stores whether the viewer is red-green colourblind, and based on this, we change the view. If the viewer wants to avoid the red-green combinations, we want to change the colours used for each bar, and we'll also display the numerical value of the bar to make it easier to read. These are the two if statements which check the viewer's recorded wishes and, based on the result, do something. And there we go. We have gone from a problem description to a final product, displaying a bar graph. We decomposed the problem into manageable components and built our program piece by piece. You'll get a chance to work on a problem yourself in this section's assignment. This will involve applying your knowledge to solve a data-driven programming problem using repetition and decision-making using techniques similar to what we just went through.